All right, mixtures. This is a very common question. You see this a lot in chemistry classes. And there are all sorts of different types of mixtures. You can have actual chemical mixtures, but then you can have things like mix different trail mixes, and so that you have this many 25% peanuts, or they'll give you all sorts of different contexts. Okay, so let's look at an example. 10 grams of sugar is dissolved in 5 liters of water. Then the sugar concentration is obviously 10 divided by 5, or 2 grams per liter. Solving a mixture problem usually requires us to analyze the amount of some substance in a solution. So now here's a typical example. We've got a manufacturer of soft drinks advertises their orange soda is naturally flavored, although it contains only 5% orange juice. Some new law comes out and says the drink must contain at least 10% fruit juice. So how much pure orange juice must the manufacturer add to 900 gallons of orange soda to conform to the new regulation? So we read it through. Oh, it's a mixture problem. Okay, what parts of the mixture problem are we dealing with? Okay, well, it's got 5% in the beginning. It needs to be 10%. And we have 900 gallons, right? So we're picking out all the important pieces. We identify the question. How much pure orange juice must be added to 900 gallons of their soda? So X is going to be the amount of pure orange juice added. Okay, now we can draw a picture we want to and try and visualize what we're doing, but this would be kind of silly to waste our time doing this. But this is just so you can visualize it. All right, we got 900 gallons of juice that's got 5% orange juice in it. Then we're going to add a certain amount of pure orange juice to it. Don't know what that is, but when we're done, it's going to be 10% juice, and the total amount of liquid is going to be 900 gallons plus the X amount of gallons that we just added to it. Hopefully that all makes sense. So we can think of kind of the volume in two ways. The volume of the total mixture. So the total mixture is just going to be 900 plus X gallons. But we can also think of the volume or the amount of a certain thing in the mixture. And this is always the key to mixture problems, is getting that secondary equation always comes from looking at some quantity in your mixture, right? So in this case, we're looking at how much of our mixture is pure fruit juice, pure orange juice, right? There'd be another question where if it had to be 25% peanuts, then you'd ask, okay, how much of your mixture is peanuts? And so on and so forth. So in the original mixture, if it was 5% juice, then out of those 900 gallons, we take 5% of that, there were 45 gallons of pure orange juice. Now, when we add pure orange juice to it, that means we're adding all X gallons of pure orange juice, right? 100% of X is just X. So in the end, we will have 45 plus X many gallons of orange juice in our mixture. But more importantly, our finished mixture needs to be 10% orange juice, right? So if we take 10% of the 900 plus X, that gives us another equation that we know we have 0.1 times this has to be the same thing as 45 plus X. And that's where the hidden equation comes from, right? So we have all this stuff, right? X is how much is added. 900 plus X is the amount of the total mixture at the end. 0.05 times 900 equals 45. That's how much juice we had, right? X is how much pure juice we added. In the end, we need 10% total juice, right? So we need 10% of the total mixture, which is going to be 90 plus 10% of X. If we actually do this math here, right? 10% of 900 is 90, 90 plus 10% X. So now we know that the amount of pure orange juice, which was 45 gallons that we started with, the X gallons that we added, has to be the same thing as the 90 gallons that we'll have at the end, plus 10% of X. Now all we got to do is solve for X, right? So move this X over here to get 0.9X. Move that 45 over there to get 45. Divide both of them by 0.9, and you get 50. So they have to add 50 gallons of pure orange juice to bring it up to the 10%. And we can double check that and see that our amounts are equal.